Awesome, we're good to go. So we're going to actually work through this question. I'm going to put the answers up on the board and we're going to have a bit of a discussion about a few of the key points as we go along. So you should have now entered your data for what is point, which is, as I mentioned, point where we're going forward driving around, where the tide's going to affect your ability to pass a point. So the first thing that you need to be able to do is sketch all of these points from the table onto your graph. So we're going to do a scatter plot. So for my scatter plot, control, add a page, and we're going to go to data and statistics. Down the bottom, we always need to put our independent variable on the x-axis. Which is going to be the independent variable? The one that is causing the change. Ollie? Time is. How come? Because time is changing and we can't stop it. Time is independent. Pretty much I cannot think of a time where the time was not the independent variable in a maths methods problem. And then for my dependent variable, I'm going to have the height. If you put them back to front, it'll make a big mess. Your graph probably won't look like a circular function at all, and you'll lose a mark for having your independent and dependent variables for being back to front. You might get consequential marks for what you do next. All right, have a little bit of a look at this graph really quickly. What's going on? Tell me about it. Ollie. It's a sine graph possibly. It's got some kind of cycle. Okay, we can see that we've got a cycle going on here. If you had to tell me what the maximum value is, what do you think the maximum value is? Maximum, 175. Where did you get it from? From hour 19, you got it from the original data. If we look over here, we can also see we've got a maximum at about 175. What's the minimum value? Minimum would be 42. We can get that from the data. What do you think like the average value is? That kind of midline that we use in our graphs to help us with our sine and cosine graphs. What do you think the mid value is roughly, if you had to guess? So our midline is about 110. What do you think the period is? When does the cycle repeat itself? How often? About 12. Okay, so we've got a period. How many cycles can we see? Looks like there's 2. Do you think it's sine or cosine? I heard some mumbles, but I didn't hear anything clearly. Sine, why do you think it's sine? Because cosine starts up the top. Okay, Toby thinks it's sine because cosine starts up the top. Does anyone have a different opinion? Lexi?
It could be either, but translated left or right.
It can be either, translated left or right. Good. So if I said this was my starting point, then I'd say that I was starting in the middle and going from there. I would just have to translate it right 4 places. Okay, what else could I do, Eliza? Yes, so they kind of, like, you mean from the midline, do they have to go the same distance up and the same distance down? Yes, because that's the amplitude. If we said the midline was about 110, what do we think the amplitude is roughly to get to 175? It'd have to go up how far? About 65, and how far would it have to go down to get to 42? About 65. So we're kind of getting, amplitude is around about 65. Good. So it could be sine, it could be cosine, depends on that horizontal shift. I would probably think it could be negative cosine because it's actually starting down the bottom and going up. So negative cosine. My point is, just from question 1, drawing my graph here, I'm starting to form some ideas about what's going on. And I've taken a moment to look at the graph and think about what's going on. All right? When is high tide? This is about tides. When do you think is high tide? Around about when? Around about 7 o'clock. This would be about 7 o'clock. When do you think is low tide? About 1 a.m. or 1 p.m. Same thing. We've taken a moment to think about the context of the question and the graph, and that's what modelling is about. But what we're going to do now is number 2, perform a sinusoidal regression analysis to determine a model to represent this data. What's a model? If I say find a model for the data, what are they asking you to find? Does no one know? Bit louder. Something that represents the data. What do we use as our something normally, Ollie? Like an equation. So we're going to try and find an equation. So our model is an equation. We're looking for an equation to represent this data. All right, so how do we do a regression line on our calculator? We go to Menu, Analyze, Regression, and then here's our Show Sinusoidal down the bottom. And it gives the equation for us. So what am I going to write? I'm going to write the equation that the calculator gave me. And that equation is, getting my colours going here, y equals 62.3 sine 0.522 x minus 2.09 plus 111. And that's the end of the equation, even though it's on the edge of the graph. All right. This is my sinusoidal regression line. A sinusoidal regression line will always be a sine equation. It won't be a cos equation. Because of what we said before, sine and cos are just translations of each other, moving it left and right. Let's compare this to what we've got. Amplitude, 62.3. Is that roughly what we predicted? Seems like we're on track. Midpoint, 111, because it's been shifted up 111. Is that roughly what we predicted? Yeah, pretty close. The period equals 2 pi over n, which is 2 pi divided by 0.522. Is that roughly 12? 2 times pi, pi is 3.14. So 2 times pi is 6.28. 6.28, how many halves? Roughly 12. We're kind of on track. We're getting there. We're looking about right. And we said that it was going... Oh no, we didn't talk about shifting it left or right at all. I know I've said that horizontal translations are not part of the course in year 11, but we should be able to manage this fact that it's just been moved left or right. We've got a translation factor going on in here. We've seen that in every other graph that we've done, so it's not completely new. If this was my model, I would not give you full marks. I would give you marks for outcome 1 because you have got a regression line. But this is not really good enough. We can do better than this. What do you think I don't like about that model? Taj? I haven't linked it to the real world. How could I link this to the real world? What's y? The height. So I'm going to use h for y. And I'm going to actually use that function notation. I'm going to say h of t. Because our rule is the height with respect to time. And then what's x? X was the time. So I'm going to put a t in there. And now that I've used this h and t and I've written my function notation, I probably should have said where h is the height in centimetres and t is the time in hours. So I've used the variables that were in the question and I've stated what each one of them are. we've now got an outcome 2 mark here because I'm relating it to the context. I'm using correct notation. Sweet. Question 3. Use your model to predict the height of the tide at 2:30 p.m. What information am I given in the question? What's the important fact here? What info does the question give us? All right, what's the questioning word? What's the question word? What's like the key word in that statement? Use your model to predict the height when the tide is 2:30 p.m. We've got to predict. So we've got to predict. What are we predicting? The height, which is h. When are we doing that? At 2:30. What's 2:30? It's a time. So time equals 2:30 p.m. Think about our question. Did we have 2:30 in any of our data? No? Right, so we don't want to write this. The time is 2:30, but for our expression, we want to actually say time is 14.5. 30 minutes is half an hour, so it's 0.5. Don't put 0.3, 0.5. So we have to find h when t equals 14.5. How do we do that? We're going to substitute that into our equation. And we can use our function notation to show that. Oops. 62.3 sine 0.522 times t minus 2.09 plus 111. And when you do that on your calculator, what do you get? Now I'm going to show you a trick on your calculator here. We have done this before. You don't have to do it this way. But what I like to do with these questions is we've got an equation and we can assume that we're going to use that equation more than once. So I'm actually going to start by going define, and then I'm going to define h of t equal to 62.3 sine 0.5, what was it, 22 t minus 2.09. Tell me if I said any numbers incorrectly. It's 111. And it just says done. So why on earth would I bother doing that? Because if I want to substitute into that equation, I can just go h of 14.5. And it does the substitution. I'm going to round off to 1 decimal place. Why would I go to 1 decimal place? Any suggestions? Because that's millimetres, yeah. I've gone to 3 decimal places up here in my equation, 2 decimal places here, because that's what the calculator spat out for me. But in this answer, I'm going to 1 decimal place. Why? Because that's to the nearest millimetre. If you added a sentence to explain why you went to 1 decimal place, you're showing an outcome 2 level of understanding. You're saying, based on this question, based on this context, I'm giving 1 decimal place. That just reminds me though, did anyone get different numbers here or more decimals than what I did? Yeah, a few people. I'll just go back to that. On my calculator, I went to menu, settings, and I actually changed this to float when I did it the first time. I went float 3. That's 3 significant figures. Why? Because when I went to float 2, my equation ended up with scientific notation in it. And I didn't like that. It made it messy and it annoyed me. So I went, all right, let's just change that. Menu, settings, and I went, all right, float 4, Sure, and now I've got like lots of decimal places and it didn't quite fit on the page, and that annoyed me that it didn't fit on the page. And I had plus 111 centimetres, 111.4, and I thought all of these numbers were whole numbers. I didn't want to do a decimal point at the end, and I kind of just went settings, float 3, because it seemed to work nicely. All right, you can choose a value that works nicely. Okay, have we answered question 3? Yes, and I've shown all of my working out. So what am I going to do next? I'm going to do question 4. What's question 4 ask us to do? Okay, use your model to find when the tide height is approximately 100 centimetres. Okay, how do we do that? We know that the tide height, the height equals 100 centimetres. So write that down. This is the key piece of information. It tells me to find the time. So when I substitute h equals 100 into my equation, it looks like this. Now, if I'm going to find out the time, what do I have to do to this equation? I've got to get t by itself. What's it called when I get t by itself? What's that word? I rearrange, if I was doing it by hand, looking for a more broad word, we're solving. How do I do that on my calculator? I need to solve this equation for t. I could even write a step under that. I could write what I'm going to put on the calculator. Why? Because now I'm showing outcome 3, use of technology. I'm showing that I know how to program the calculator to do this for me. I'm showing I know how to apply the skills that I've learned and how to do it on the calculator. When you do that, let's think about our graph for a moment. I know I'm doing a lot of backwards and forwards and talking quickly, but I want to give you time to practice today. When did 100 centimetres? So 100 centimetres is here. I can see 1, 2, 3, 4 points where it's 100 centimetres. I've also got another one over here. That one's not possible. Why is that one not possible? Because it's negative time and we cannot go back in time. No one's built a time machine yet, as far as we know. All right. What about, would there be more solutions over here if I kept going? Yeah, of course there would be. I just haven't extended my graph screen. So what do I add to the end here to restrict where my answers come from, Taj? The given line, good, and then what? Why did you choose 24? Because that was the last hour of the day. That's what our data represents. We don't know what happens after that. The tide could be doing anything. So this is just predicting the tides on one particular day. That kind of comes to a question that's coming up. So on my calculator, here's a trick. Because I've defined that equation, I actually can just go solve h of t, solve that equation equal to 100. Using this define means you never have to write the equation out more than once. If you want to write out the whole equation again, you can, that's fine. And then the given line, for those who don't know how to find it, control equals, given, 0, control equals, less than, t, control equals, less than or equal to 24, hit enter, there's my numbers. And I've got all of these decimals again. So, can someone read out my answers for me, please? T equals 3.66. Give me 4 decimal places. What's the next one? What's the next one? Correct. Is it on your calculator? Is your calculator in degrees if it's got a very different answer, not radians? Change it to radians, please. Who else has got an answer for me? Do you say 336? 036? 006. That's all right. Right. Do these look like times to any of you? No. So a couple of tricks. How do I change this decimal to a time? Because this is 0.66 of an hour. So what I'm going to try and do, I'm going to change that to minutes. The way I change it to minutes is dropping all my whiteboard markers here. The way I change it to minutes is I just take the decimal part and then I multiply it by 60. So it would be 3 hours and 39 minutes. Round this one off, that's closest to 40. I would say that the time here is 3:40, and then that's going to be AM. This is important. It asks me to do a time, and you can upgrade your level by changing your decimals to an actual time. Times 60, 21.7 is like 22 minutes. So 10:22, and again that's AM. Repeat, 0.7006 times 60, 42 minutes, and so it would be 15:42. I'm going to say that will be 3:42 PM. If you say 15:42, you won't lose a mark. If you say 15:42 PM, you will, because 15:42 PM is not a time. 15:42 is a time in 24-hour time. Again, technicalities, but this is about context to what's going on in real life. So those contextual elements are important. 23.9 is like 24 minutes, so that'll be 10:24 PM. Sweet. All right. 5. When would you recommend a four-wheel driver tries to pass through what is point? Justify your reasoning. So remember, this was about people going around a point in a four-wheel drive and the tide's coming in. This is where we have to do our outcome 2 skills and show how we understand what is going on in the real life context. There is no maths formula for this. This is you showing some kind of connection to real life. So what's the connection to real life? If you're in a four-wheel drive and you're going to go around this point, when are you going to do it? Low tide. So when would you recommend a four-wheel driver goes around what is point? 1 AM. 1 PM. Would you tell them to go both? Would you say, hey, go at 1 AM or 1 PM? If this is a potentially risky crossing where I'm going to get my car flooded and wrecked, would you go in the middle of the night, in the dark, and go and attempt it? No. Look at you smiling and say, yeah, I would. Okay, well, you're stupid. Don't do it, unless you want to risk your car. But this is where the contextual information comes in here. Yes, we do want to go at 1 PM. That doesn't mean it's the only right answer. You could say 1 AM or 1 PM, but then you might add to that, but at 1 AM it will be dark, so either have good lights or a friend to help you. You know, recognising that it's going to be dark at 1 AM is part of the contextual justification for the question. Remember, it says when would you pass or when would you recommend, and justify your reasoning. So I'm expecting a sentence. I would actually do this. I would recommend they aim to pass at 11 a.m. And this is a perfectly okay answer, but it's not okay yet, because I haven't justified why I said 11 a.m. Can anyone think of a reason why I would say 11 a.m.? Yeah, because at 11 a.m, the tide's here, it's already pretty low, and it's only getting lower. So if I turn up at 11 a.m. and it's still a little bit too high and a bit risky, I can just wait. But if it looks like it's okay, I can try and pass that point. And if something goes wrong, then I've actually got a couple of hours to get myself unstuck before the tide comes in again. So I would say something like, I would recommend aim to pass at 11 a.m. because the tide will be pretty low and if I get stuck, I've got time to recover my car before the tide comes up again. Before the tide rises again. I wouldn't go at 1 a.m. because it is dark. So I've taken into consideration the two possibilities, and I've given some context and a justification for why I selected it. And my justification's about the context, not about the maths alone. All right. Question 6. Discuss how effective you think your model will be for predicting the tides in a week. Justify your answer. What would you say? Do you think that this would still be a relevant model in a week's time? No? Why not? So we had this conversation last lesson about the tides. We know that the tides are affected by the moon. We know that the moon has its own cycle. Maybe you do, maybe you don't know this. But I would actually, for question 6, be saying, well, the tides are affected by the moon. The moon's cycle is changing, so the tides are unlikely to be the same in a week's time because of the moon's gravitational pull. This is probably not a good model for 1 week's time. Something like that. It's the justification. You're expected to bring in your prior knowledge about the world around you in a justification question. Wow, I'm going for way too long, so I'm going to really try and speed this up. So I won't write anything for question 6, I just spoke about it. When I put this video up on YouTube, you can review what I said. Question 7, find another model to represent the tide at what is point in the form y equals a cos b x minus c plus d. To speed this up, let's actually use what we had here. This is our model, and we're doing something like this. Okay, we already spoke about the amplitude's probably 65. What's the amplitude in the equation? A. So I'm going to do 65 cos. Then B is the period. We said the period should be 12 hours. So the period, how do I find the period? So the period's calculated using 2 pi on n, and I want this to equal to 12. So we can use a little bit of algebra. I'll move the n to the other side. 2 pi equals 12n. Then I'll divide by the 12. N equals 2 pi divided by 12. So n equals pi over 6. Okay, so B is pi over 6. I'll leave the C till last. D is how far up we've moved it. We've said the midline will be at about 110. So we're going to stick 110 on the end of the equation. All right, let's actually see how we go with what we've got. I can add an equation onto my graph. Let me just delete this one so I can see it a bit clearer. Menu, analyse, plot function. We wanted 65 cos bracket pi on 6 times by t, except the calculator doesn't know t, it only knows x, plus 110. Okay, how's my graph looking? Different, looking pretty different at the moment. How could I change it? I could translate it across, good. How far do I want it to go? 7. You say 7? All right. So I can go back to my equation. In my brackets here, I'm going to put a bracket, x minus 7, close a bracket. That wasn't too bad. 7's not bad at all. I like 7. It's not the only answer though. I could have gone minus 65, so it's a reflected cos graph, and only moved it across 1. It actually looks exactly the same. That's why it didn't look like it moved. The equation's changed. I don't know if you can see that minus 65 and the minus 1. So why I'm showing you this is we use the amplitude, the period, and those translations to help us start with the equation. And then I can test what I think it is on the calculator by going menu, analyse, plot function. And you get your calculator to draw a graph over the top. Okay, I'm going to end it there. What you have to do now, if you want more help with this sheet, you can ask me for a little bit more of a depth of discussion. Otherwise, you've got time to work on your set of questions, your summary journal, so you're prepared to do the SAC tomorrow. Mariah, could you please press pause for me?